Oh, sorry. I was actually speaking. I didn't know my my mic was mute. So, as I was saying, this is the assignment I gave us last week, right? And I there are some things I noticed basically from the assignment, which we're going to be going through. Some of us, most of us didn't turn in our assignments. Unlike previous assignments, the turn-in rate was not as impressive. And even those some of the assignments that were turned in, they didn't really get the questions right. I don't know if you didn't read the question well or you didn't just understand how to approach it, but we're just even some persons are expected to implement it or to answer the questions correctly. It's not like it was wrong or anything, but we'll go through that and we'll just say where we made mistakes, right? And when we need to correct ourselves. And I also realized that the last class was not so friendly. So yeah, it was not so friendly in terms of the concept. So the live video, the class recording is there to help you go over what we did. So at this point, you have no excuse, right? You have actually have no excuse because the essence of dropping the live class recording is to just ensure that we go over what was taught at our own free time, at our own pace. YouTube has options for you to slow down the video or speed up the video. So you can just basically take your time to go through everything that was taught in the class. So by now, I believe everybody has gone through that video. There is no, I don't see any reason why you shouldn't, unless you already understand everything that was taught. So and I said it several times on the Google Classroom that before you answer the assignment questions, you should go over the video rather, all right, and understand what was taught so you would be able to answer the questions correctly. All right, so I'm going to quickly go through this assignment and then tell us what we have for today. Proceed from there. So as I do, I pick up a particular assignment that I liked. This particular person, Babatunde, he actually answered most of the questions, or all of the questions, exactly how I wanted it. So I was impressed with it. Kudos to you. So we are going to be going through it using these answers. Right. So the questions here, questions. Let me see. Okay, I gave 6 questions basically, right? And I gave 2 data sets. The retails transaction data set I have been using ever since we started machine learning, or rather even EDA, and also the Fetch California data set too, the one that is inbuilt in Scikit-Learn, right? So these 2 data sets serves two purposes, right? And the retail transaction data set is for the pre-processing part, right? Because we did pre-processing in the last class, and we also trained the model in the last class. So the one from sklearn will be to train our model, and the one from for that I gave us the retail is for the pre-processing. So I just want to know, be sure that we all got what was taught in the class. So first question. Let me just scroll down. So I don't know. So the first question here, encode all and categorical variables using one hot encoder. So we talked on one hot encoder in the last class, and basically we know what one hot encoder is for, right? And we demonstrated it in the last class, and we saw how it is used. So basically, one hot encoder encodes categorical variables, right? So before I proceed, I just want to ask this question, quick one. Why are we encoding our categorical variable? Why don't we just use it directly? Um, building our model. Why do we have to go to that stress of encoding our categorical variables? Can someone give me an answer to that? Why do we go through that stress? Because the preprocessing techniques, some of them are very stressful to do, right? So we have to we have no choice than to just encode these variables. And why exactly are we going through the stress of doing that when we could just um take it directly to the ML model? So okay, someone said to convert to numbers. Yeah, yeah, obviously you're converting it to number, but why are you converting it to number? Okay, Adimo said because ML does not support non-numeric data. Okay, that's in line with it because that's the language it understands. Which who is the easier? What exactly is doing the understanding? Okay, so it makes it machine friendly. All right, we encode because ML uses numerical values. ML works. So yeah, basically, you are all in line with the answer. So basically, um, we encode categorical variables to numerical variables, right? Because ML algorithms, computer don't understand text, so we have to give them numbers. It is numbers that these ML algorithms would work with. So whatever ML algorithm you're going to be working with, even in the most advanced level, doing using deep neural networks and the rest, you are going to have to convert every of your features to numerical variables, right? So in this case, we are still working with normal numbers and variables that are just there, normal continuous variables and the rest, right? That is our features. So if you finally maybe advance yourself in machine learning and you start working with AI and the rest, you see that some of our inputs, right? Some of our data are actually pictures, images. Some of our data are text, like sentences. Some of our data can be audio. So there's a lot of work to be done to convert those data to numbers, right? So you don't just take it directly into the ML. You have to convert everything to numbers so your computer can work with it. So that is just the idea behind this. So in this case, we are going to be using one hot encoder to do the encoding of categorical variable. Right, in the last class, we showed us that. So this is one you should be paying attention to because this is what you're going to be using most of the time, right? There was something I was trying to remember in the last class, and this was it, right? I don't know why I forget some of these things sometimes, but I was trying to like directly output a pandas data frame, right? So you can actually directly output a pandas data frame after you've transformed it, right? So instead of getting an array, you can get a data frame that can help you better visualize what you are transforming. So the question, encode all categorical variables with one hot encoder. Now I want to ask us a question. Why are we encoding transaction dates? Why? I saw so many of us encoding transaction date as part of categorical variables. Why? Like I was just going through some of the assignment and I was like, I don't understand. You saw the different variables. We have customer ID, product ID, transaction date, payment method. Out of all these categories, we have just three variables. Out of all these variables, we have just three variables that are categorical. We have product ID, we have payment method, we have product category. The rest are not category, right? The rest are not categorical data. Transaction date is not a categorical data. It is a date time data. It's just that in that it is not yet encoded or it has not been converted to date time yet, but you can't classify it as a categorical data. So for those of us that were categorizing or sorry, encoding transaction dates, you are wrong, right? You are wrong. So what I needed us to do was just pick out these three categories, right? And then encode them with using fit transform. So this was what I was expecting. You get a first data frame for the first category, you get the second data frame for the second category, and you get the third data frame for the third category. So remember I even said that after encoding the question two, I said after encoding different categorical features, then concatenate the newly transformed data into one variable. What I mean here is that the three different variable data frames you've gotten from the three different categories, I need you to concatenate them to have one single data frame. And I even gave you a tip here. Your new data frame should have 12 one-hot encoded features. So it should have 12 columns basically. So for those of us that we're having more than 12 columns and you're even adding other features, right? Quantity and the rest, I didn't ask for that. I needed this. Remember in the question I said don't go beyond or don't do what beyond what I am asking. So you can do extra stuff around what I am asking. I love that. I love when we add new things, but don't go beyond what I'm asking, right? So it kind of just makes everything more difficult to assess. So now the question two is to concatenate them, right? So basically you use pd.concat, right? And then you put your three data frames here, 1, 2, 3, and then you specify the axis you want to concatenate. So this is just a very smooth way. Like I love how this person just answered everything like straight to the point. Cool. Question three. Um I now understand why question is so very important in data science. Yeah, exactly. So question three, you have a variable price. Use min max scalar to scale the values of price to be between 1 and 2. That is the first part of the question. Scale the variable what? Price. That is the first part of the question. And then add the transformed variable to your previous data frame of one hot encoded. So basically you are to scale price, right? You then have a data for price and then add a new column to that 12 encoded variables you have already. Like just straightforward. You can see here you remove price from your data frame, use initialize a min mass scalar object, right? And then fit transform the data, and then you have a scaled variable of price, and then you add it to the encoded data you have before. So you're now having 13 columns. Like it is just as straightforward as this. There's really nothing difficult here. So that's for question three. Question four, then we move to the next phase of the questions, right? We are basically done with preprocessing, just to just assess a little bit of what your preprocessing knowledge. So from Scikit-Learn, fetch or load the fetch California housing. So this is a data set in the Scikit-Learn library, right? This is built in and separate. So this is the first part of the question. Load the data set and then separate it into features X and labels Y. So we thought we looked at that. So if you come here, you see that everything has been imported here. So a very good practice is to import all your libraries at the beginning. So you import all your libraries at the beginning, and then you can now start doing your work, right? So and try to demarcate the ones that you imported, like without just imported directly, and the ones you imported specifically. So just make your code look very neat. So we'll go back to question. But I'm taking my time to do this question because it's very important that you understand all these things. So load the fetch California house and separate it into features X and labels Y. So now, and just to let you know, today's class might be a little bit extended to, let's say, 10 to 15 minutes. I hope we are all okay with that. If we're not okay, just let me know in the comment in the live class. So I would know how to put everything into the 2 hour that we have for today. So we'll load the data set, which is this, right, by just calling the particular data set and using the bracket as a function. So it's basically a function that returns a value, right? And that value is where we can get our data frame from. So there's a particular parameter that you can include here that will just make the data you are getting turn directly to a data frame. It will convert it to a data frame. So I told us initially that everything is integrated, pandas, Scikit-Learn, and the rest. So if you come here and say as frame, put a parameter there, and we say true, true, and we run this. Let me load this first, import everything. So wait for that to import. Still importing. Okay, that's taking a lot of time. Let's just wait for this to import. So basically, once you've imported that, you can just, let's go back to the question. All right. So as frame.true, we'll convert it to a data frame. So as you can see, as we display the data frame now, it is in a data frame format, right? So you can appreciate the different variables better. You can see the different variables we have here. We have house age, average rooms, average bedrooms, and the rest. So basically, that's just how you can integrate pandas. But if you leave it like that, to give you an array, numpy array. So whenever you are loading a data set from maybe Scikit-Learn libraries, just ensure you put as frame equals to true. So whenever you see something like this, they have a bracket. Just know there are things you can put inside that bracket that will modify the output or the functionality or the way this particular function or class acts. So it's left to you to explore and to see the different things you can do. So this is just it. You always use can come here, just see the data frame, right? So you can now separate the data.data x, data.target y. So you've separated basically the two. So you can see them, right? Come and say display. Display, right? So you have your x and y now. So that's for question 4. Question 5, split the x and y into train and test data sets, right? So I'm expecting you to divide the features and the labels that you've splitted or that you separated initially into train and test data sets. So in the last class, it was during the end of the class that I talked about train and test, split our data set into train and test. So can anybody remind us of why exactly we are splitting it into two different data sets? We are splitting into train and we are splitting into test. Can anyone remind me of the reason why we did that or we are doing that? Okay, so I just want to be sure that we are getting an understanding of machine learning in general. So I want to know where we are in terms of our knowledge on machine learning. So someone said to avoid bias. Someone said Yusuf, one for training the model and the other for assessing it. Okay. To evaluate a model with not already texted model. I don't know. To train and yeah, basically. So yeah, you all are getting it. You all are getting it. So basically it's it's to like train our data set with a specific data set, right? And then you now use a different data set that the model, once you train with a data set, you have a model. A model is now what you can use in making predictions because the aim of the training or creating a model is to make predictions. So, and you want to assess your model. You want to ensure that your model can accurately predict new data. That's why you're having tests. That's why it is called test. So once you've trained it, you can now use your test data to make predictions and then evaluate your model. So that's just it, basically. You all got it. the training data set is for training your model, for learning the patterns, for understanding the relationship between your features and your label, while the test is for evaluating the model that has been trained already. I hope we get that. So that is basically it. So we split it, and this is the syntax for splitting. So you would use this a lot. Like basically, almost every time you are doing a machine learning model, you always split. So this is the syntax for that. You have your X train, you have your X test, you have your Y train, you have your Y test, right? So this is how it is. So sometimes it might be easy to confuse, right? Sometimes you might put S train, Y train, S test, Y test. So it's just understand that this is the pattern: X, X first, Y, Y following. So then you have your two data sets here, the X and the Y, and then test size. I remember I told us what test size is. Test size tells us or specifies the percentage or the proportion of our data set that will be assigned to our test data set. So I'll use this assignment to just explain some concepts. So that is why I'm taking my time here. So I'll use it to do revision and explain some concept before we move on where we are for today. So now this test set, now if depending on what you specify here, this function will split it into that specified proportion. So we have 0.1 here. 0.1 basically is 10%. So 10% of your data, of your entire data set, will be allocated to the test data set. If I change it here and I put 2, it will be 20%. So 20% of our entire data set will be allocated to our test data set. If I put 50, that means half will be used for training, half will be used for testing. So there is something you need to understand about this, the volume of your test and your train data set. So the convention is to always give the highest volume or highest amount to the train data set. Why? Because you want to let your model see enough data, right? You want it to gain enough or get enough information about that data set so it can generalize and it can know how to predict when it sees another data set. Basically, we are going to talk about some concepts in next week. Yeah, next week we're going to talk about what we call overfitting and underfitting. So these are problems that we can come across during training. So we're going to talk about overfitting and we're going to talk about underfitting. So, but just understand that we need to give enough data to the training data set, right? If we give small data to the training data set, it will train, but it is not going to be robust. It's not going to be, it is not going to know a lot about your data set to be able to make accurate predictions, right? It's just like, let's say, a footballer now. So let me just put it another way. Training is just like giving your model experience. So if you give it plenty data, you're giving it plenty experience. If you give it small data, you're giving it small experience. And it is that experience that it is going to use to make decisions. And you know, someone with better experience can make better decision. Someone with lesser experience would make will not make a very good decision, right? So that is just the idea behind this. It's just like a footballer now. Let's say a footballer that has been playing for, let's say, 15 years, 10, 15 years. So the footballer has gotten a lot of experience. And this experience, let's just term it training data. The training data in this sense is what? Football matches. So the footballer has played a lot of football matches. So the footballer has been able to understand the patterns in playing match. The footballer has been able to see different things while playing, understand so many things, right? Because of the fact that he has played a lot of matches. Because there are some things that will happen in one match, right? That will not happen in another match. There's something that happen like once in 10 matches, right? So he has to play a lot of matches to be able to gain that wealth of experience. You understand? So now compare that footballer that has played for 15 years and have a lot of experience. That footballer has basically been trained on a lot of data sets. So the training data set in this case is large because of the experience. Compared to a footballer now that just have like 4 years of experience, right? That footballer has played just few matches. So the footballer has not really seen a lot of things that the other footballer has seen. So when you bring those two footballers now side by side and you say, oh yeah, based on your experience in football, can you tell us what will happen when when we have so thing, or let's say when you have this particular tactics, or just basically you can just bring up anything basically, but you know that in any case the footballer with enough experience can confidently and accurately tell you what will happen because he has seen a lot of things, he has seen a lot of data. Do you understand why the footballer with lesser experience he will try to predict based on what he has seen, but for the fact that he is limited in the volume of data he has been exposed to, he cannot make accurate predictions. That's the idea behind splitting or train and test. Training is the data that the model will use to learn and gain experience, while test is like the new data that has not been exposed to him before. So if he has gotten enough experience, he can make predictions on new data. I needed to explain this so you understand it very well. Like this is a very, very core concept in machine learning. All right, so let's move on. So now we split our data set into two using 10% of our test. So generally, you should use a very smaller percentage for your testing and a bigger percentage for your training. And then this random state now, I explained it in the last class. So random state is just to capture that particular instance when that splitting happened, so you can reproduce it. Because during this splitting is a random process. So once you run this split function, the data set is shuffled, right? See, don't be thinking about the fact that we are still in assignment. We've started class already. It's just that I'm using this assignment to teach us some things. There are some things I wanted to teach us today that I wanted to teach us train and split, but since it's already here, great and fine. So don't worry about that. So it's part of what we're supposed to talk about today. So random state is basically keeping an instance, or just keeping that state in which the split was done, so we can reproduce it, because the splitting process is a random process, right? So we can capture that randomness. Let's not go into randomness in how random stuff is being done in Python, but it's actually not random in the sense of what randomness is. So anything that you hear in Python that is random is not actually random. It's just a particular is what we call pseudo random. So let me not even go into that, but just understand what this random state. So if you do the splitting with random state of a particular number, and you want to like repeat this process again, you make sure that you put this particular number in your random state parameter. So it will give you the exact same split that you had before. If you don't include this, right, in your splitting, if you split now, to give you a particular split between the train and test. If you split again, to give you a different entire configuration of split. So the data set will be scattered around. So that's just the idea behind that. So these are the two most important parameters in this train split function. So there are others that you can just check out. So as you can see, this is the shape of the X train and the Y train, S test and the Y. So you can see the train data set is 18,000, while the test data set is 2,000. So you can see the proportion there. So now after you split, the next thing is to just fit your linear regression model. So as you can see, we'll just call our linear regression class and assign it to a variable. This is basically creating an object of this particular class, which is linear regression. And then you just use this object to fit your train data. You say call linear.fit, and then you say S train and what Y train. So this is the process of learning. This fitting is the process of learning, right? So we're going to we're going to quickly go over the rest of the questions. So basically, you can use your model that you've trained on your trained data set to now make prediction. As you can see, we're now making prediction with what? The S test, right? Because we didn't train it on the S test. We want to be sure or certain that our model can predict accurately. So we'll just call the predict method here and passing a new data set. So what we are passing in here is just the independent features. Now we're not going to be putting the label because we want to predict the labels, you understand? So you pass that to a new variable, and then you can just display the variable here. So you can use scatter plot to visualize the strength of your prediction. So this is actually showing us that the predicted value and the actual value are actually close, right? So you can see the direction is they are stacked together. So the scatter plot will give you an idea of how well your model is making your prediction. So these are just the basic routine you follow, right? It is basically the routine you follow while creating a model. I'm coming. Someone asked a question here. So regarding question 3, adding the price you want to code out data from, I don't understand. Okay, you don't understand why we did that. So basically, it's just I'm just trying to give you an idea on how you would usually have your data. So once the encoded categories are the features, while this skate price is like the label. So once you have this data frame, you can now use it for your training. You can now split it into um, X and Y. So basically, so that shouldn't be an issue. I was just trying to test, check out your preprocessing ability. So that's it for the assignment. So just know where you didn't do well and correct yourself. Right. So for today, we're going to be looking at logistic regression. Right. So last week we introduced Scikit-Learn and looked at linear regression, right? So what we just looked at now, we built a linear regression model. Let me go over that again, and you can see okay. So last week we did linear regression, right? So we looked at a whole lot of things, data preprocessing. We looked at training and splitting. That is testing. I was supposed to talk about this today further, but I just did that now. So we also looked at building a linear regression model, which we just looked at now. There are other things you can do in evaluating your model. So evaluation during hyperparameter tuning class, we're going to look into details. We're going to look at all these evaluation metrics, right, that we've talked about: MSC, RMSC, MAE, R2, and the rest. So we can look at how we can make these metrics, we can make them better, basically. So we are going to look at hyperparameter tuning in the next class, that is next week, Saturday or Sunday. So basically, we've looked at linear regression and we've been able to cover the basics, right? So I just believe that we understand how to approach that now. So we'll just move on to what we have here. So now we'll look at logistic regression. Yeah, so we've looked at the conceptual aspect of logistic regression, where we talked about a whole lot of things. Let me just open the material here. Right, we talked about what logistic regression is, what the logistic regression formula, sigmoid function, types of logistic regression, evaluation metrics in logistic regression. Okay, and I think I didn't include assumptions. It's basically you can just look that up yourself. But we've talked about all these concepts already in logistic regression. So today we're going to be implementing logistic regression in Scikit-Learn, in Scikit-Learn. So all these things that we talked about, now we're going to implement it and see how we can build a logistic regression model. So yeah, let's just start with that. So that is basically what we have for today. So there are two things we're going to be doing today. We're going to be training a binomial or binary logistic regression model, which we have here, right? Which we have here. And we're also going to be training a multinomial logistic regression model. So after that, we're going to be looking at that. So we're also going to be training a multinomial logistic regression model. So these are the two things we're going to be doing today. And we evaluate our model. So all these things we talked about the other class, false positives, false negatives, and the rest. So we're going to talk about a lot of that. And I think that is where we're going to spend most of our time in today's class, right? Because as I said before, building a logistic regression model or building a model generally, the building part is the easiest part, right? The part that you spend most of your time on are usually pre-processing and what evaluation and ensuring that your model is doing very well. But the building part, which you do model.fit, is very straightforward. As you can see, it's a one-line code. So today we are going to be skipping the pre-processing part, and we're going to be going straight into building our model and looking at the various metrics that we can use in evaluating our logistic regression model. So be sure that I'm not missing anything here. Yeah, so that's what we're going to be doing. That's what we're going to be doing. So let me just create a new file that we're going to use to work. So if you notice today, I'm talking very slow, right? So I want us to follow along, right? Because I noticed that the last class, I was going fast for several reasons. For the reason that we have enough time then, and also needed to catch up with things. So I realized that some of us were not following up with what we're talking about or what we're discussing. So I just want to know, just let me know in the live class which is better or if it has any effect at all. So basically, I just want to give us the best experience that we can get, right? So to ensure that um we are learning very well. So let me just know if I'm going too slow or I should increase my pace or I should just maintain the same tempo, right? So you are basically the ones that would determine the experience of the class. So let me just wait for your responses. Okay, okay. All right. So all right, that's actually okay. That's actually okay. So we'll just proceed from there. Just give me a minute. All right. So we're going to be looking at binary logistic regression, right? Binary logistic regression. Let's come here. So remember in the class on logistic regression, we talked about the two types of logistic regression. where we divided it based on the output that we can have, right? So we can have two categories as the label, this or what, that, right? And we can have more than two categories, right? We can have several categories. So in the case where you want to predict something that is categorical, your best bet is using a logistic regression model. You can't use a linear regression model. You just can't. You need to use a logistic regression model, right? So and there's yeah, basically that's it for that. So I just something just came to my mind now. In the last class, we remember we did feature engineering and preprocessing, and there are some techniques that we said we're going to look at subsequent classes. So just keep this in mind, right? Keep this in mind. We're still going to be looking at them in case you are wondering why we missed that. So we're going to be looking at how to do all this. So, but for today's class, we are going to just be focusing on building our models, right? We're going to be focusing on building models. So now today, we'll look at this logistic regression. Now, as I was saying, when you have a task that you need to predict a categorical label, you use a logistic regression, right? And it is very, very straightforward. Like Scikit-Learn has made a lot of things easy for us, right? You just need to understand the functions. You need to understand the functions. You need to understand parameters in the functions. And you need to understand when to use what. So there are a lot of things to use, there are a lot of functions, there are a lot of parameters and everything, but you need to understand when to use all these things. So that is why the technical knowledge is very, very important. So the implementation rather is very important. So understanding the concept is great, right? But now implementing it is going to also require some effort from you. So let me just go back to the lecture note and take us through what we have. Right. So binary, let me zoom in. Right. So binary classification is a type of classification. I'm just going to recap, right? That involves classifying instances into two possible classes, right? And logistic regression is a commonly used algorithm for binary classification, right? It models the probability that a given input belongs to a particular class. Remember, I took my time to talk about this in our logistic regression class, and I told us about the sigmoid function. And yeah, I know we have asked this question before, but what does the sigmoid function do? Right? The sigmoid function is very key in logistic regression model. So, but what does it do? What is the function of a sigmoid function in logistic regression? Let me get answers from us. So I just want the class to be interactive as I'm teaching. I'm also knowing that I also know that yeah, you are following and you've not forgotten some of these concepts. So what exactly does the sigmoid function do in logistic regression? So I'm waiting for us to give an answer to that. And I'm just having the same set of persons answering. I would love everybody to be involved in this. This is part of the experience, right? So we're not giving mark for answering. If you feel it is part of learning, basically. The thing about feeling it is that you will never ever forget that thing in your life. That is just it. Like once you feel it and you're corrected, you never forget it. And you pass that stage, you've grown. So just give answers to whatever it is I'm asking, whether you know it perfectly or not. So I don't really mind. I don't really mind. So yeah. So someone said it maps value between 0 and 1. It gives 0 and 1 values. Yes, no, true, false. Probability 0 to 1. Okay. So we are just giving a generic answer to that, which shows that we have an idea of what it does. So yeah, basically we are okay. I'll just wait for some of us to give answers. Okay, that's impressive. Okay, great. So yeah, we've actually given good answers, right? So please just give me a second. Give me a second. Okay, so we've gotten that. We actually so segment function basically takes in as input a continuous range of number, and it gives an output between 0 and 1. So that output is a probability value. So to the probability value is actually what we now use to make the prediction. So the threshold basically is usually 0.5. So if the value is below 0.5, then it will classify it as 0. And if it is above 0.5, it will classify it as 1. So that is just the idea behind that, and the basic um, that is the idea behind logistic regression. So now we've talked about that. I don't want to go into all those things again. So today we're going to be looking at how we can implement it in Scikit-Learn, right? So as you can see here, Scikit-Learn provides a user-friendly implementation of logistic regression. I've been saying this several times. Like Scikit-Learn is makes things easy, like very, very easy. So now today we'll demonstrate how to use it for binary classification using the breast cancer data set. So that was why I introduced us to this data set initially, because you just quickly build a model. You don't need to now start going to Kaggle or looking for a particular website, or kind of just thinking about you get your data. You can just quickly get your data from Scikit-Learn and run your model and do a lot of things and learn, right? So this data set that are here, they are not for production purposes. You don't use it for real world you don't use it for real world problems. You just use it to learn and to understand how to use Scikit-Learn. That's why they have it there at the go. So we're going to be using the breast cancer data set, right? So these are the steps in building your model. I've said this several times. First, you load your data set, whether it is from sklearn or whether you are getting it from outside source, and then you have to use pandas to read it. After you do that, you split the data set. So the good thing about this sklearn data set is that the data set is ready for model, right? It is ready for model building. You don't need to do any pre-processing on it. It doesn't have any categorical variable. So that is why it is focused on helping you learn how to build models. So there is no pre-processing technique here. That's why I give you a different data set so that you can learn how to pre-process your data. And you can as well explore to, I showed us places where we can get data set from Kaggle. And I believe the class rep posted a particular website some other time. Please, after this class, can you repost it or send it to me so I can post it on the Google Classroom? So it's actually a repository where you can you download a lot of data set from. Because without data set, you can't do anything in machine learning. So you need data sets to work. So the next thing is to split, right? So you split to train and test. Now, there's something I'm going to talk about splitting, right, when we get there. But let's move on. After you split your data set, then you can now train your model. Train your model and get your model basically. And you can now use that model to make predictions and then evaluate your model. So these are the things we are going to look at today, but for logistic regression model. So now let's quickly go back to the rough sheet. So the first thing is what? To load our data set. Load our data, still zoomed in. So to do that, we just say from sklearn dot data set import load breast cancer, right? Run that. So it should run. If it doesn't run, then I think I made a mistake in the name. I was planning to actually do something at the start of the class, but I just feel we need to dedicate like 30 minutes for that, but it's not going to be in this class. Because most of us, I get a lot of messages about error messages. See what I'm facing. I don't know what's wrong with my code. It is not running, this and that. See, one thing about coding or programming is that bug is inevitable. Because what are you trying to do? You are trying to talk to your computer, right? And so if you don't talk appropriately, it will give you errors. So that is just what an error is. And getting an error doesn't mean you don't know what you are doing, right? It's just pointing you at the right direction. So I believe some of the times I was teaching, you might have seen error messages live here, which is very, very normal. So it's just pointing you at what exactly you are not doing correctly, right? So I'm going to actually try to just take us over how to read error messages and approach them, hopefully in subsequent classes. I just hope we have enough time to do that, but it's not part of what we are supposed to do. But if I'm not able to do that, I'm going to send us a video so we can watch on that. But whenever I get an error message, please try to read it. Don't shut down when you see it. Try to read it. And that last line of your error message, right? That last line is the main problem. So if you check the last line in your error message, it will tell you the specific type of error, right? It will tell you the specific type of error and then give you the description. And so basically, I don't want to even go into that because of time. So, but just understand that getting error in your code is actually not a problem. It's just pointing you at the right direction. And reading an error message is a very, very it will make you very, very efficient as a programmer. So you don't just shut down every time you see it. So a lot of time you see me as I'm demonstrating getting error messages, and we solve it immediately, right? So because I'm able to understand what the error is, and some of the times it might not be something you solve immediately, right? So now you've imported your data set, you just load it and say data equal to you say load breast cancer, and then you put your column. So this particular bracket is not for fancy. They did not put it here, so you would say this is a function. No, the bracket there is to take in what we call parameters, and these parameters can do a lot of things. They can modify the behavior of the function. Do you understand? So we can come here and just put there's what we call as frame. As I said before, say true. So whatever output you're going to be getting here is going to be in a pandas data frame directly, so we can appreciate the data very well. We can see it and understand it better. So if you come and say, okay, before we do that, before we read data, there's something else I want to show us. So this data that we've loaded here is not the data itself. It is a collection of different things, right, that is pertaining to this data set. So if you want to see the different attributes of this data, you just use your dir data. So you're going to see a lot of things. So you see it has different attributes, DESCR, it has data. This is the data we usually use to get your X features. It has data module, it has feature names, right? It has file name, it has frame, it has target. Remember, this is your Y variable. It has target name. So you can just explore it and see exactly what each of them is. So if you want to understand what this data set is, you can use this describe, which will describe the data set for you. Come here and say data dot DESCR, right? And you're going to get a lot of things, right? So this basically is what breast cancer Wisconsin data set. So these are the characteristics, right? So these are the attributes. This is summary statistics, right? This is the people that created it and the date it was created. You can see it was created in 1995. And you can see this is it. So you can get a lot of information pertaining the data set, like any data set that you import in Scikit-Learn. So this describe attributes will describe it for you. Now the next one, data. The data attributes would give you the data itself, right? So normally we just use data.data to give you the pandas data frame, since we've already put as frame here. If we remove this as frame and come here and see as frame, and we come here and see data.data, data will give you a NumPy array, which you are not really understanding. But as you can actually configure it to be a pandas data frame, right? By using pd.data frame and using these featured names as the column names, right? Which most of us did in the assignment, but this one just make your life easier. So you do that, you get your data.data, so you can get it directly here. So you can see we have a lot of features here. We have mean radius. So these are the features of a particular observation. So this is like a feature or the parameters of a breast. So you have the different arguments or the different variable that describes a particular breast. So these are the things that you are not going to use to predict if that breast is cancerous or not, basically. So this is a very, very good project that you can do, right? A very, very good project. So you can predict even before the person starts noticing anything. This machine learning model can pick up slight details that will give you an insight into whether this is becoming cancerous or not. Although this is a very basic model when it comes to predicting breast cancer. So I think the recent ones are using images. You just have your images or your X-ray images of a breast, and then you pass it, and your model will be able to detect features that point at cancer or wherever it is that you want to detect. So now the target is usually the Y variable. So in this case, we have two targets. So if I come here and say target.unique, it will give me two values, 0 and 1. So this is a binary problem. It has two different variables. So two different values rather. So you are just good to go. You've understood your data set, right? And then next thing is to assign them into your X and Y. So you say data.data is X. Someone was asking why X is capital letter. That is the convention in machine learning. So data.target, you can make a small letter. It's not going to affect anything. So basically you've separating into features and label. All right, so you've separated into features and label. The next thing to do is what? Splitting into frame and test data set. So in a normal situation, you don't just go from here to here. Before you even get to this place set, you would have done a lot of pre-processing that will take your time. It's just because this data set is straightforward. That's why we are jumping like this. So normally you do pre-processing, you convert a lot of things, you remove null, you do this, you do that, and everything that we've learned so far. But just for the sake of learning the model building aspect, we're just going to be going straight into. So you split it directly, and you see, come here and say X frame, X test, Y frame, Y test, right? And you use train test split. To do that, you have to import it and say from sklearn.model think model selection. You need to know all the different modules in Scikit-Learn, right? So say train test split. So you import that and then you come here and say train test split. So first parameter will be what? I need you to take me through this right now. So the first argument here will be what, followed by what? Test size followed by random size. You're jumping. What happened to the data? You have the data. The first parameter will be your x, followed by what? Followed by, because of time, followed by y. So it is y here, right? And then you indicate there are different other parameters that you can have there. So if we come here and you say train test split and put question mark, you're going to get the different parameters in these particular functions. So you have your arrays, which is your x and y, right? You have your test size. By default, it is none. You have your train size. So this one is, you can use this for test size. You have your random state. You have shuffle, and you have stratify. So I'll quickly, okay, now by default, shuffle is what? True. So what this shuffle mean is that, let's come here. What is shuffle? Let me put test size. Let me see the x dot shape, y dot shape, print. It's not even plenty itself, so I'm not going to give much this thing. So we have 569 observations. So we are not going to split much. We are just going to give, like, let's say 100 or 200 to our test data set. So we can have enough for training. So we just say 0. Let's say 1, the same thing, 10%. 10% should be okay, right? And then you can come and say random state equal to, you can use anything. I can use 20, right? Just make sure that whenever you are redoing it, you're using the same number. So shuffle is another parameter. So shuffle by default is what? True. What is shuffle dot equal true means that once this function wants to split the data set, before it splits it, it randomly shuffles it. Like, let's say you put different balls inside a bag, like 500 balls, 569 balls in a bag, and you want to split it into 2. Before you split it, you shuffle it. You use your hand to just shuffle it, right? And then now split it. So it is going to be a random process. That's why we're having random states here. Do you understand? But if shuffle is what? False. Let's say shuffle is false. We are going to, it is going to split it as it is arranged. So it will not be like, you will not have anything randomized or anything. So there will be no need to even do this, right? So basically by default, shuffle is always true. So you don't even need to add it again, right? So, and those are just the basic ones you need to know. And the last one, stratify, that is based on the proportion of the labels, right? You can come and check the proportion of the target label, that is y dot value count, value is it count. So you can see the first class, that is the true, the positive case, we have 307. For the negative, we have 212. Remember what I said before about accuracy and imbalanced data set. So this data set now, is it a balanced data set or an imbalanced data set? Based on the proportion of positive and negative cases of breast cancer. Is it a balanced? Is the data set balanced or not? From your own perspective, based on what you're seeing here now, the positive cases has 357 cases, while the negative cases has 321 cases. It is balanced. It is approximately balanced. So for it to be balanced doesn't mean it will have the same number. You get, so at least the distribution is somewhat similar. So let's assume in this case we're having 480 something, and here you're now having 100 and something. So it's actually not balanced, right? So based on your intuition, you can know whether it is balanced or not. So it will influence the kind of metric you're going to be using moving forward. So let's just move on. So once you split your data set, like the next thing to do is now to build your model, right? To build your model. So that is very straightforward. So you have to first, you want to use logistic regression, right? So you have to import it and say from Scikit-Learn. Someone said, I will answer that question later. Let's move on. Someone asked, why can't I just import Scikit-Learn? But let's quickly import from Scikit-Learn.logistic regression. Import I made a mistake here. So what am I supposed to import? Like what sub-module am I supposed to import here that will allow me import logistic regression? So this one is just a random question based on what we've been seeing so far. The logistic regression is what under which module in Scikit-Learn? Exactly. Linear model, right? Linear model. So we say linear model, import logistic regression. So some of us might be confused. Logistic regression, linear model. It's not supposed to be logistic model. So logistic regression, if you follow what we thought, is actually derived from a linear model, right? The difference is just the sigmoid function. The sigmoid function takes in the output of the linear model and converts it into values between 0 and 1. So it's still a kind of linear model in a sense. So just keep that at the back of your mind. So once you've imported it, you can just come here and say your model. You can name it any. You can say log reg, right? Log reg, and then you say logistic regression. Now, remember I told you inside this bracket there are a lot of things that can happen that we can do, but let's just go with this for now, right? Just move. But if you want to see that, you can come here and say what logistic regression. Okay, don't know why it's not, but let's say log. They don't give a documentation for that one. You can go to their website to see that, right? So, but there are a lot of parameters you can put in here. A lot of parameters. So, well, let's just move on. So once you build or create an object for your model, you can now train your model. How do you train? You just say log reg dot what dot I'm waiting for an answer. Like I'm actually enjoying the interactiveness of the class. So I want us to be interacting as I'm teaching, we are responding. So once we are leaving this class, we are living with all these things that we've answered. We remember a lot, right? But it is different from when you don't answer anything. You are just listening, or some of us are practicing along, and that's better. So that's I consistently ask questions. So dot what fits, right? And then you put your X train and your what Y train. So this is the code for training your data set. You run that, and why is it giving us an error? So the same name error. So why is this now? I want us to debug this code. I was talking about error. So what do you think we should do now to solve this bug? What do you think is the problem with this error? Can someone tell me? What do you think? Based on what we've done, what do you think is the problem? It's telling me name. Remember, I said the last thing is the what you should focus on, right? First. So the error here is what? Name error, right? It says name logistic regression is what? Not defined. So what do you think we should do? Exactly. I just want to clap for us, but I don't know. That is what you should do. You have to run this cell. When I imported this logic, I didn't run the cell, so it didn't take in it didn't bring in logistic regression into the namespace. So it was actually searching for this logistic regression, but it couldn't find it in the namespace. In our namespace, namespace is basically all the variables in our current working environment. So if you run this again, you can see that it's going to work. Forget this is just a warning, right? It actually works, but this is just a warning. So we've run our model, right? And we've trained it. So we've trained it with our X train and Y train. So I can just change it to m beta equal to 1000. The n beta. What is the function again? Self. I think max beta something. Put 10,000. All right. So now, basically, this is an argument that you can use. So this is called a parameter. In our next class, we're going to look at the different parameters in linear regression and logistic regression and other algorithms. So there's what we call hyperparameter tuning. No, let me not even go there now. But once we get there, we are going to understand all these things. So in this bracket, right, we can have a lot of stuff there. Okay, I think the reason why this didn't work before was because we didn't run that cell. So come here again, run logistic regression, right? We're going to get this. So this would show us all the parameters that we can have in our logistic regression class. So we have penalty, we have dual, we have a lot of stuff here. We have fit intercept, we have all these things are parameters that you are seeing. And hyperparameter tuning is basically changing all these values that we are seeing here to improve your model. So by default, there's a default value for everything. So in case you need to improve your model, you can actually manually change the values. So if you come here, you see where I did that max eta. You can see max eta here. Yeah, you can see it here. The max eta is 100, right? What this max eta means is that your the number of iteration of your model is going to be 100. So it is going to have to okay, well, we've not talked about that yet. There's what we call back propagation or convergence. So tomorrow we're going to look at that. But basically, if the maximum number of iteration is 100, and then when you come here to train your logistic regression model, and it goes 100 times, but when it reaches that 100 times, it has actually not gotten the best accuracy, or it has not actually minimized your error to the lowest, then you will see that error that you saw here, right? So the reason why I increased it was to make sure that the number of iteration or the number of times the training happens is enough for the regression or the algorithm to converge. Convergence is basically getting to the lowest error, because what you are trying to do here is to minimize the error in your model, right? So basically, that's what this max eta does. I just wanted to explain it, but don't get confused. This is not the class for that. I am just trying to explain what I just did now. When we are looking at hyperparameter tuning, we're going to look at all these things, right? We will look at some of the things we can change here. Not everything that we're going to change here, but we'll look at some of them. So even in the multinomial regression that we're going to look at in few minutes, we're going to look at how we can change something in this particular parameters, one of these parameters, to adapt our logistic regression model to become multinomial, to be able to predict multiple classes. So this is it. If you check for linear regression too, you see the same thing. Let me just quickly do that. So I'm just trying to help you understand or just get comfortable with Scikit-Learn. If I come here and say linear regression, right? And I come here and say linear regression. You see, linear regression has just four parameters. So it does not have a lot of parameters that you can tune like the logistic regression. So it has fit intercept, copy X, end jobs, and what positive. So basically, it doesn't have a lot like logistic regression does. So that's just it for the parameters that you can put into these brackets here. So you can see we put max iteration here to be 10,000. That's why it took time to run. If I change it to, let's say, 100,000, you see it will take a long time to run, a longer time. So if depending on the number of iterations, it will depend on the amount of time to spend on the training. So once we've trained our model, we can come here and start to explore or evaluate our model. So the next thing to do is to now test or use our model to predict the X test data that we split the other time, right? So remember, we'll say evaluating our model with X test. That is the purpose of the X test for evaluation. So now you can come here and say log reg, right? And we'll say dot predict. So now I just want to show you something. We have another method called predict proba. Let me zoom in. Predict proba. So this predict proba will show you the probability itself. It will not show you the ones and zeros and everything. It will show you the probability that is predicting for each class. So if I say predict proba and I come and say X test, this is what I'm going to get. I'm going to get probability values. So I'm going to get probability values, right? And if I come and say just predict, you see I'm getting ones and zeros. So we've been using just predict since, right? But predict proba can also come in handy in some situation. So this is the first, these two values here is for the first row. This second set of values for the second row. So the first one here is 0. This is 0 class, and this is the 1 class. So this value here is the probability of the true value being the negative case, that is 0. And this one here is the probability of the label being the positive case, that is 1, right? So based on what you're seeing here, you see that this one has a lower probability. I don't know why it is. You just have to round it up so you get a better understanding of this decimal. So this one should be 0.9, right? 0.9, that is 90%. So if I come here and say, you see that it is 0. It is predicting 0, right? Because if I come here, okay, I need us to understand this. So remember that the first prediction here is 0, right? And I come here and change it to predict proba. You can see this first value, what is 0.9, that is 90%. So basically, the threshold here is 0.5. Okay, this row, this column here is for the 0 class, and this column here is for the first class. This proba can be confusing at first, but just take your time. If you don't understand it now, that's fine. You can always go over the video again and read some materials to understand it better. But just know that this first row, in the case of binary classification, this first row is what? The 0th class, that is negative class, and this is the positive class. So if depending on the probability here, it's going to determine the predicted value. So the zero class has 90% probability. That is 0.9. That means between this zero class and the first class, this is the one with the highest probabilities. Hence, the model will predict this first value to be 0. So if we come here, we'll do the same thing for each of them. So the one with the highest probability will be the one that was selected, basically. So you can see you have, I think, about 569 predictions here. Don't know if it is okay. No, not 569. That is for the S test. We have, I think, 100 and something or so number of predictions. So you can use that for a lot of things, which we are going to demonstrate as we move on. But what you are going to be working with mostly is predict. So this predict will just give you the output directly. So just do not confuse yourself. Just focus on this predict method, right? So we'll assign it to a variable. You can say y pred, right? So we have that variable now, and we also have y. Remember y that we did before, but we are not going to compare it with y. We are going to compare it with y test, because we want to see if the predicted values for x test is close enough to the actual value for y test. So there are a lot of things we can now start doing to evaluate our model performance. So first of all, we will not use scatter plots like we did in linear regression. So if we come here, we'll just come here. Let's try to use scatter plot to see what we're going to get. I will say import matplot lib.pyplot as plot. Import. I will introduce us to a new library. Import cborn as SNS, and so there are some other things we need to import for evaluation. So say from Scikit-Learn.metrics, import accuracy score, import accuracy score, import confusion matrix. Remember confusion matrix, right? Import classification report. So now you can see I'm importing a lot of things in one line from one module. So it's possible to import it like this, right? So in this case, we can just import logistic regression, linear regression, but sometimes it can actually be very long. So we'll just come and just import this classification report separately because of the length of this. So just make sure that your code is always clean, so when others are reading it, they won't be confused about what you're doing. So you can say classification report. So these are the different things we're going to be using to evaluate our logistic regression model. Remember, in the linear regression, we're using RMSE, MAE, and the like. So, but for today, we're going to be doing all this. So remember, we've talked about confusion matrix before, right? Remember confusion matrix when I thought was, let me quickly go and show us. So basically, this is what confusion matrix is. It shows us the true positive, false positives, false negative, and true negatives in a table, basically. So from there, we can get a lot of other things, right? Accuracy too, and precision, recall, F1 score, and the rest. So these are the things we're going to be looking at today, basically. So we'll come here and we've imported all this already. We'll then run it and then come here and we can now check the score. The accuracy score is the first thing we're going to do. And in this case, accuracy score is a good metric. Why? Why are we going to depend or rely on the value of the accuracy score? Because I said earlier or in previous class that you don't depend on accuracy score if the data set is something. I need us to remind me of that. There was a particular condition that needs to be satisfied for us to depend on the accuracy score. So what was that condition? I believe we mentioned it earlier in this class. So if you remember, please let me just know in the live chat. So we've imported the accuracy score, so we can just come here and see accuracy. I'm waiting for our reply before I move on. Accuracy score, and I'll come and say why test and why predicted. So you can see nobody is saying anything. Okay, so we can see here that our accuracy score is what? 0.96, which is what? 96.5%. Right? 96.5%. So which means that our model is very, very good. That means it predicts accurately 96.5% of the time. That is just what its accuracy score means. So this is the first thing you always check. Exactly, Chukudi, you are correct. When there are no imbalances, that is very correct. So, and remember I asked us initially here, if this data set is imbalanced, and we said what? No. So in this case, we can actually use accuracy score as a metric to assess our model. So you can say, okay, our model is doing very fine because the accuracy score is 96.4% or 96.5%. That is actually very good. So, but we don't just end. We can also evaluate some other metrics, use some metric evaluation. So remember, we imported metrics. So you can come and say confusion matrix, and you say y, the same y test and what y pred. You can see it gives us a 2x2 NumPy array, right? But normally confusion matrix is always usually in diagram or in chart. Now, if you remember when I introduced you to data visualization, I told us about heat map, right? Now we are going to use heat map to display our confusion matrix. So we've shown our accuracy score. Just put it in a variable, accuracy, right? I'll come here and say print and say accuracy is equal to, and I'll say accuracy, right? So this will print our accuracy. I can just round this off, so round, so that it's not give me like 1 million values. So basically our accuracy is what? 96%. Right, to even make it better, I can come and put percentage here and come here and multiply by 100. So you can see our accuracy is what? 95. Let me make it 1. Our accuracy here is what? 96.5%. Right? You see how I made use of string formatting now to make this look better. That is just by the way. So now we want to visualize our confusion matrix so we can understand it better. I imported a new library called Seaborn using Seaborn heat map. So Seaborn is a library for data visualization in Python that is built on top of Matplotlib. So it is a more advanced or more easier tool to use, right, to give us better visuals and everything. But Matplotlib is the foundation of visualization. So Seaborn is just built on top of Matplotlib, right? So you can quickly use Seaborn to visualize our confusion matrix. So we'll put the confusion matrix into so you can say C matrix, right? We have our C matrix here. So using Seaborn, remember we imported it as what? SNS, right? As this is the alias. So we'll just come here and say SNS dot heatmap. There is a method that called heatmap that you can use to visualize an array, something like what we saw the other time. So we'll just put the C matrix that we have right? So if we run that, we're going to get this. We're going to get this. This is the 2 by 2 confusion matrix that we had before. But this is not the end. We have to edit this chart so we can understand it better. So first of all, I told us that Seaborn is built on Matplotlib. So you can actually use Matplotlib figure to determine the size of this Seaborn. So I can come here and say plot dot figure and say fig size equal to, let's say I want it to be 4 by 4. So you can see it's reducing. 4 by 4 I think is too much. Let me make it 4 by 6. No. Let's say 4 by 3. Okay, I'm just trying to get the perfect size for this. So I'm just trying to get the perfect size so you can see it very well. Okay, let's just use 4 by 2 basically. So now you can see that we are using Matplotlib figure to determine the figure size of this Seaborn map. So that is to tell you that Seaborn is built on top of Matplotlib. So the interaction is very, very tight. So there are some parameters we can add here to make this Seaborn or this particular visual easier to read. So I can say annote, there's annotation equal to true. If I put that, it's going to put the values inside these different boxes, right? So I can also come here and say C bar. This, I don't want this bar to be here because it's not giving anything. I can say false and to remove the C bar. So I'm just having this. So I can as well come and use plot dot x label and say this is the predicted values and say plot dot y label and say this is what the actual values, right? So I can come and say plot dot title and say confusion matrix. So you can see how I'm using Seaborn or Matplotlib functions on top of a chart I created with another library. So I'll just show you how they are well integrated. So what is this problem? Side 2E. Right. So basically, let me just use plot the show to remove this text that I have up. So this is it here. So this is our confusion matrix, basically. I don't like the shape of this. I don't know why the shape is like this. Okay, so this one is okay. So you can see now, this is the actual value and this is the predicted value. So in this place now, this place means that the actual values that are negative, the model predicted 13 of them correctly, right? And predicted 13 of them correctly and predicted one of them wrong. Do you understand? I'm trying to explain this confusion matrix. For the actual value that is positive, the model predicted one to be negative, which is wrong. So this is false negative and this is false positive. Do you understand? So normally, diagonally, by as you are seeing here, you are supposed to have a higher value diagonally than the other side because this is the true predictions we're having. So if we have very high predictions diagonally, that means your model is doing well, right? So if you have 0 here and 0 here, that means your model is perfect. It accurately predicted every single thing correctly. But if we have like 5 here and we have like 8 here, that means it predicted some values wrong, right? So out of all the numbers or out of all the observations. It was just 2 that were wrongly predicted. So this is just how confusion matrix presents the whole your model performance. So you can just assess it from this confusion matrix. So it's a very good way to assess your model, but you don't stop here. There's some other things you can do to assess your models. So basically, we've gone through some things. We've created our model. We've trained it, right? We use it to predict our tests. I introduced predict proba to us the other time, right? And I also showed us the accuracy score and the confusion matrix. So there's something else that we're going to look at. What exactly is this classification report? Why is this giving me an error? Classification report. Okay, I is not here. Okay, now we're going to look at classification report. We've looked at accuracy score and we've looked at confusion matrix. So what classification report will do is that it will give us a report of all the metrics that we can use to evaluate our logistic regression model. So I can just come here and say classification. I've imported it already, classification reports, and then say y read. Remember, we are using the predicted value and we're using the predicted value and we're using against the actual value, which is y test. Remember, we are not using y train because y train is one we use for training. Test is the one we are using to test our model. So we will have to print this out so it will be displayed properly. So this is basically what you get in your classification reports. So these are the 2 classes, 0 and 1, right? And this is precision. Remember, we talked about precision before. This is recall, and this is F1 score. F1 score is a combination of precision and recall. So if you want to consider both of them, you use F1 score. But if you want to consider just precision, you focus on precision. If you want to consider recall, you focus on recall. Now, support basically is just the number of times this class appears. So you can see that 0 appears 14 times in your y test, y1 appears 43. So this is kind of imbalanced basically in your y test. So, but let's just move on. You can there's something that you can do to solve this. But basically, this is your classification report. It shows you a lot of metrics that you can use to assess your model. You can see this is your accuracy here, 0.996%. So now remember what precision is. I told us this before. Let's go back to the chart. I told us what precision is, right? These are the different metrics in our classification report: precision, recall, F1 score, support, and the rest. So I'm just going to explain precision, recall, and some of the rest. So because those are the important ones that you need to focus on. So precision now is basically you are comparing. Now in precision, you are focusing on just the predicted positive values, right? You are not focusing on the actual labels. That is the y test. You are focusing on y read. So what you are trying to get there is the ratio of the positive values that were correctly predicted over the total number of positive predictions. I'm going to say that again. Precision is basically calculating the ratio of the correctly predicted positive values over the total number of predicted positive. So in your precision now, or in your predictions, you might have, let's say, you might have a lot of positive predictions, right? But all those positive predictions, some of them might not be correct, right? Some of them might be false positives. You get. So precision is actually trying to minimize false positives in your model. So there are some cases where
You want to make sure that your model does not have false positive. It's very important for your business. Let's assume you are a business person and you have a data scientist out to create a model. So you tell them that, okay, see, it's very, very important that we don't have false positives at all, because it's going to impact negatively our business. So you will focus on reducing the or making sure that the precision score is very high. So these are the different situations where you focus on these metrics. Your recall basically is different. Your recall is actually, you are comparing the correct predicted positive, right? Which is the same thing as precision. You are comparing the ratio of the correctly predicted positive. But now you are comparing it with all the positive values in your actual label. Precision, you're not comparing with the actual label, you're just comparing it to the predicted label, or with the predicted values rather. That is your Y pred. But recall, you're comparing it with your Y test, right? So you can see here it's saying that of all the instances that actually belong to a certain class, which is positive, how many were correctly predicted. So you want to know how many. It's confusing now. Yeah, it can be confusing, but just pay attention. Like, you can always go back to it. To be honest, I would just have to say this. Personally, it took a lot of time for me to understand the differences between precision and recall when I was learning. It was not something I grasped immediately. So I understand how it might be now for some of us, right? So, but just still focus regardless, and you will definitely get it. So that is what precision is. And recall is you're comparing the correctly predicted positive values with all the positive predictions in the actual class. So you get a value for each of them. So recall, you're trying to actually mitigate the number of false negatives. Do you understand? You're trying to mitigate the number of false negatives. While in recall, you are trying to mitigate or reduce the number of false positives. So these two metrics, they are very important. Very important. Hey, my head won't burst. It's not burst in Jesus' name. So F1 score now is like a combination of precision and recall. So that sometimes you actually you are not focusing on just reducing false positives. You also want to reduce false negatives. So you can use both precision and recall. And F1 score is actually a harmonic mean. It's a way to combine both of them and to bring balance, right? So that is it for that. So support is actually the number of actual occurrences of the class in the data set, right? So basically, that's just it for that. Accuracy is the ratio of correctly predicted observations to the total observations. So this one is just you're not taking accuracy now. You're not taking note on the different classes, or like precision and recall. Precision and recall are like accuracy, but accuracy you're just checking everything, right? But precision and recall, you're actually checking specifically the class, that is the positive classes, and the proportion of correctly predicted positive classes to the proportion of the total predicted positive classes. That is for precision, and the proportion of correctly predicted positive classes to the total number of positive classes in the label. That is for recall. Don't worry, you get it. You definitely get it. So macro average, this one is basically just an average of all the metrics you have here, right? And these ones, they are not so important, but the one I want you to understand is these ones that we've talked: precision, recall, F1 score, and accuracy. So now we'll just summarize it. We loaded the breast cancer data set. We split the data set into training and testing. We trained the logistic regression model on the training set, and then we evaluated the model using accuracy, confusion matrix, and classification reports. Now, all these metrics they are seeing, the reason why they're abstract now is because you actually don't have any problem you are trying to solve. So when you have a business problem or a project that requires you to think about the implication of your metrics on the task, then you now start to understand all these metrics very well. So you definitely appreciate them better then. So this is basically how you approach a logistic regression model, basically. Right? You understand? Basically. We've never talked about ROC score and AUC. If we have time, we'll talk about that. So this is for binary logistic regression. So for multinomial logistic regression, it is the same step. We'll just change some things, the same step. So training a multinomial logistic regression model involves classifying your instances into 3 or more classes, right? So basically, you'll see how we're going to do that in Scikit-Learn. The same process, right? Right, the same process. Just we need to have a data set that has a label that is more than 2 or 3 or more categories. So let's just come here and illustrate that to us. So now we're going to use the same notebook that we have here because of time. So we have a particular data set called, I'll just copy this, come here, we import load digits. So I'll change this to what? Digits, load digits. Now we now have a different data frame now. So everything we're going to be doing from here is going to be load digits. So this load digit data basically is let me display the X. I come here and say display X dot head. So basically this load digit is a data that what you're trying to do here is you're trying to predict a particular image, right? Whether it is between 0 and 9, basically, you're trying to predict a particular image. You're trying to train a model to be able to predict handwritten image. So there's a new attribute we have here, which is images that we didn't have in the load breast data set. So if we just come here and we say data.images, let's say we want to check the first sample, you see this is what we're going to see here. So just to visualize this, we can use plot.imshow, and we're going to see something like this. So basically, what does this look like? What number does this look like? This is what I hope everyone is still following me. Are we lost? Yeah, this is 0, right? So exactly. So if we change the number to 4, like the index to 4, that's the 4th data at the 4th index. You see we have another number. I think this looks like a 4, right? If we change it to, let's say, 8, we'll see that this looks like, I don't know what this looks like, sure, but let me see the shape of my data sets. So we have 1,797 digits, right? So if I put 1,700, the digit at the 1,700 index, I'm going to get this 5. So basically, that is what my data, I'm just trying to show you what the data set is. So each of these variable is, yeah, so it's actually a very, very compressed or low resolution image, right? It shows so that we'll be able to like train models, simple models on them. So this is 7 by 7 image, right? And I don't really want to go deep into this, but basically the features are the pixels in the image, in each image. So the first observation is one image, and it has 64 variables or 64 features. So each feature corresponds to one of these square that you're seeing here. One square, one square, one square. So if you start doing convolutional neural network, which is an advanced machine learning technique, these are the things that you'll come across. These are the kind of tasks you'll be working on, kind of using your images or trying to build models that can understand images and all those things, object detection and the rest. So, but it's just a very basic one that we can use to illustrate multi-class logistic regression. So what we want to predict here, we want to predict if an image is either 1, 2, 3, 4, 5, 6, 7, 8, 9, based on these features that we have here. That is just the tags for this particular data set. So we already have, these are the labels that we have here. We already know them, but we want to train the machine so that when we pass in a new data, that is a new 64 pixel data, it will be able to tell us what that image is, right? So now we've loaded it, and then we have our data here, right? So you can just come here and split as we've done before. So now in this logistic, everything is the same thing. Like the process of doing the binary and the multinomial is the same thing. So the only difference is that you have to come here and then you would include a particular parameter. Let me see if I can get that. Logistic regression. So this parameter, which is multi-class, right? So multi-class now is a parameter you can change. So it is left at auto. Auto means it can actually adapt to whether binary or multinomial. But in this case, I want us to specify, so we'll see it. So if you scroll down, you see the different values you can put for it. So in this case, you have for multi-class here, you can use auto, you can use OVR, one versus rest, and you can use multinomial. So multinomial is what we want to do, right? So we're going to select multinomial, right? So we'll come here, let's go to our model creation, and we're going to leave this. We're going to come here and say multi-class. I'm going to say equal to what? Multinomial. So we are basically telling this logistic regression class that the data set that we want to predict here is a multinomial data set. That is the output. The label has classes, different classes, like more than 3 classes. So we'll just put that and then we'll train it basically the same way we train binary. So this is the output, right? Max it at 100,000 and then multi-class multinomial. So now we can evaluate our model the same way, right? You can come here and run all this. You can see that our model is what? 98.3%, right? So 98.3%. And if we do this confusion matrix, this is what we're going to get. We're going to get, let me go out. We're going to get, you can see we have more values because we have 9 classes, 0 to 9. So this is 0, this is 0 digits, 1 digit. So these are the different classes we have, right? These are the different things we can predict as a label. So we can see that our prediction is actually very good because in this diagonal, remember I told you what you should focus on is the diagonal, right? The values here should be greater than the values outside. So you can see that we have a wrong prediction here, 1. We have another wrong prediction here, 1. So basically in this case, the actual prediction is 9, but our model predicted it as what? 8. In this case, the actual prediction is 5, but our model predicted it as what? 9. So, and in this case, so these are the things that you can use to assess your model, right? So you can check the classification report for that. You see that it is longer, right? So it will give you classification report for each of the different class, right? You can see precision of 0, precision for 1, precision for 2, and the rest. So basically, these are the things you would use to assess your model. So creating a multinomial model is not a difficult thing. You just have to specify it here, right? And then you train your model using the data, the multinomial data that you have, basically. So that's it for that. Like we've actually gone over training a binary logistic regression model and a multinomial regression model. There are a lot of other things that we do in evaluating our model. I'm just trying to check time, right? But we've actually covered what we want to cover today. So, but we have the ROC curve. Remember, we talked about the ROC and the AUC curve in the logistic regression class. Remember this thing, right? So it's another way we can assess our model too, but we'll do that tomorrow, right? Tomorrow we're going to look at that. I want you to digest the one we've done today. Just go through it, understand it, and get comfortable with it. So tomorrow we're going to look at this, and tomorrow we're going to be introducing new algorithms. We're going to be looking at decision trees. We're going to be looking at k-nearest neighbors. I'm also going to be looking at support vector machine. So tomorrow is going to be interesting. It's just going to mostly be, we're going to be looking at the concept, and we're also going to be looking at the implementation. It's going to be a lengthy class, so we can use about 2 hours, 30 minutes for it. So just prepare yourself for that. You can read ahead for that class, but that is it for today's class. We've gone over how to train logistic regression models using the built-in data set from Scikit-Learn. But don't be deceived. What we did here now is not the typical thing you would experience when working with logistic regression model. We skip the pre-processing part because the data is already we skip the pre-processing part. Someone said network. I just hope it is not my own network. So because the data set is already ready for us to train, so we didn't do any pre-processing, right? So, but when you have a data, your normal data, you have to go through a lot of pre-processing techniques, and that will take a lot of time. So this is just to help you understand how to train your model. You understand how to train your model and how to evaluate it, right? So this is just giving you an intro into that. So from next week, we're going to be going deeper into all these things. We're going to be looking at hyperparameter tuning, how we can use grid search CV, how we can use randomized search CV to get the best hyperparameter combination for our model. And we're also going to be looking at overfitting and underfitting. That is next. So next 2 weeks, I think that is when we're going to start I think we should start our project then, either then or the upper one. But basically, we are already wrapping up, and you should be getting familiar with machine learning at this point. So we've actually spent this the 3rd week now, so it should not be a new thing to you again. Put all you can into it, learn all you can, read what you can, watch the videos that I dropped, the YouTube videos, and everything that we're going to really be doing, right? So this is real stuff. This is real stuff. Data science is not a walk in the park at all. But trust me, with what we are doing, is going to be easy for you. I just believe I'm doing my best to break this down for you to understand, right? So take this as gold, right? Watch the YouTube videos, take your time, and it's not going to be much of an issue for you. So I'm actually deliberately not touching those so technical stuff at this point, so you can get the basics right. You understand? So when we are moving forward, you already understand the basics, then we can now start building on what we've done already. So that's going to be it for today. I intentionally didn't touch some things we're going to touch, which we can do tomorrow, right? We'll do that. That is ROC and the AUC, right? We're going to do that. And also, okay, yeah, ROC and the AUC, and how to set threshold too, which is in combination with the ROC and the AUC curve. So we're going to look at that tomorrow, and then we're going to wrap up with that, right? So this is it for today. We've come to the end of today's class, and I'm going to be giving time for questions. So if you have any question, please let me know by raising up your hand, and I'm going to unmute you and have you ask a question. So yeah, I'm going to give 5 minutes for that. Any question? All right, Ademoye, I'm unmuting you now. You can go on to speak. You can speak now. Ask a question. Ademoye, you raised your hand and I unmute you. Please, you can speak and ask your question.
Good evening, sir.
Yeah, good evening.
Thank you for the class. You are really
Yeah.
trying a lot. We appreciate your efforts for keeping it simple for us. Actually, I don't really have questions to ask for today's class because I haven't gone through it, but to know where I don't understand where. But you really try a lot. So I want to ask questions about handling missing value with simple inputter.
Yeah.
That day is not a simple inputter, but as I did it, I use it conveniently for particularly numeric data. But when it comes to those categorical data stuff, it doesn't work for them. I want to ask if encoding those category variables is the same as using simple inputter. So that's just my question. I think you get me right.
Yeah, I get you. So, yeah, for simple imputer, you'd it work best with numerical data. So if you want to be missing values for your categorical variables, it's best you either use your pandas function for filling in missing value, or you convert your categorical variables to numerical variables and then use the simple imputer on it, right? So most of these Scikit-Learn functions, they work best with numerical variables. So once you give them categorical, they begin to misbehave, right? So either you use your pandas method or you convert the categorical variables to numerical, which we did, that is the encoding, and then you use your simple imputer for that. So, but you can explore other methods of doing that, but this is just what you should try as regards working with missing value. So that's also a very valid question, and it shows that you are doing something. So yeah, thank you for that. Do you have any other question?
Thank you very much, sir. No, sir.
So yeah, someone asked the question in the group chat, which I was going to answer. He said, I think Joseph, that why don't I import or why don't we just import skill like that, right? And use everything. Now, Scikit-Learn is a very big library, a very, very big library. I'm trying to remember. Okay, yeah. Scikit-Learn is a very big library. And if you import Scikit-Learn itself, you say import Scikit-Learn, you are importing every single thing in Scikit-Learn into your notebook, into your workspace. And that will consume a lot of resources. The things that you are not using will be consuming resources in your computer because you are importing it, you are loading it into your memory. So everything will be there in memory, and even the ones that you not use will be wasting memory. And if you are training machine learning model, you need all the memory, all the resources that you can afford. So importing everything singly helps saves this memory space and resources. So anyone you need, you import it. Anyone you need, you import it. So you are importing the necessary libraries and you are saving space in your computer memory. Do you understand? Is that clear? Do you understand, Joseph, or the person that asked the question? So you don't just import everything, right? Unlike pandas and numpy, where it is not so big, right? So and you'll be using a lot of things, like a lot of functions that you might not even know, right? You can use a lot of functions, so you can just import it at once and then be using them like that. So that's just it for that. I hope I've answered that question. So yeah, Kim, please can you speak? I'll just unmute you now.
Hello, good evening.
Yeah, good evening, Kim. David.
Thank you, sir. Yeah, thank you. My question, sir, is about the assignment you give us last 2 weeks on machine learning.
Okay.
Machine learning. Yes, it was a Google form.
Yeah.
Yes, returned to me, and then the grade award. I don't know whether that was a problem. I don't know. But I responded to the assignment, but I got that assignment returned.
I believe you sent me a message regarding this, and I asked you if you submitted the assignment because submitting on the Google form is different from submitting on Google Classroom. So once you finish your assignment on Google form, you have to come back on Google Classroom where the assignment was given and you submit it there, right? I believe because the ones I see and the ones I grade are the ones that are submitted in the Google Classroom. So if you didn't submit in the Google Classroom, even if you did it on the Google form, I won't see it.
Okay.
So that. But just send me a message on my DM. We'll resolve that. Just send me.
Okay.
I send me a DM again, and I'm
Okay.
going to respond to that.
Thank you so far. You have been great, sir.
All right, you're welcome. Okay, Abadnego, I'll be taking your question. Yeah, Abadnego, I don't know. Can you hear me, Abadnego? I don't know if you can hear me, but you are on mute now. You can unmute yourself and speak. Timothy, you can unmute yourself and
Hello,
okay,
sir.
yeah, Abadnego.
Good evening,
All
sir.
right. Yeah, good evening.
I tell you, sir. First of all, I appreciate. Thank you so much for the really putting much effort to at least to just to make us to understand. Like somebody like me, I'm a beginner of the course, and really I'm benefiting a lot. Uh, I just have a complaint. Like last week, the assignment. I tried to upload it in the Google Classroom, but I couldn't submit it. I don't know what was exactly the problem, but I tried all my best about 2 days, but I couldn't do it. Thank you.
Oh, okay. I believe that should be a technical issue from your end. What device did you use to upload it? Is it your phone or your laptop?
I normally use, sometimes if I have network problem on my laptop, I use my phone. But now the day for instance, yesterday I was using my laptop. I couldn't, there was no improvement, so I have to use my phone and the same problem. I had the same problem.
Okay. Okay. But you've been submitting previous assignments on the Google Classroom, right?
Yes, but I have had like two cases like this problem, like two cases now for two assignments. But that ones
So I
I've been
believe
submitting. Though the first one, I had problems that I was not feeling fine for about three assignments, but I couldn't submit those ones. But after those ones, I've been submitting.
okay. I don't know exactly. I can't really tell what the problem is exactly, but if you have that issue, just send me a DM and I'll try to see how we
Okay,
can
sir.
go about it. So for now, we'll just
Okay,
do the manual way and try to resolve the issue as soon as possible.
okay, thank you, sir.
All right. Okay. Yeah, Timothy, you're on mute. You can go on to speak. I believe your hands were raised.
All right, thank you very much, sir. Thank you for the class. Please, my question is concerning the assignment, this last assignment. Out of the transaction, there is a column, product ID. There are some product ID that they are just numbers. So I'm actually confused about the product ID being a categorical data because I knew the one that was in the question was like alphabet B, C, D, and so like that. But there are some product ID that they are just numbers like customer IDs. They will be just the number. Is it because the product ID in this one are B, C, and D that's why we classify it as a categorical data, or because I'm really confused.
Yeah. Yeah. In the data sets, we have three categorical variables, and based on what categorical variables are, I sent a video on data types recent few weeks ago. So I don't think I'll have the time to start going over what categorical variables are. But once you have definite or finite numbers of categories in a variable or in a column, you consider it a categorical variable. So, for example, your product ID, if you use the unique function in pandas, that is the column.unique, right? It's going to give you the unique values in that column. So, for instance, the product ID has four unique values: A, B, C, D. The payment method has four unique. And also the payment category too has 4 unique. So these are the categorical variables there. Now, the reason why some of us failed this question was because we classified all objects, all all variables that are object as categorical variables, which is wrong, right? So sometimes Pandas just assigns object to any variable that it doesn't know how to classify it. For example, the transaction date now is correctly supposed to be a date time variable, which I taught us how to convert it. We're using PD to date frame, PD to date time rather. But some of us included transaction date because it is object. So that transaction date is not a categorical variable, right? It's a date time variable. Now, customer ID, that one is different. It's a mix of numerical and this thing, text data. So it's a different thing entirely, right? It is not a categorical variable and it's also not a numerical variable, just an ID, basically. So you can't really use it for any analysis. So most of the time when you are doing analysis, unless you want to get a specific, it's basically used for referencing, or rather it is used for indexing, right? When you are using a data frame with that kind of column, you set the customer ID to be the index because it is unique. Everything here is unique, right? So if you've worked with SQL before, you understand all this relationship, foreign key and primary key and the rest. But this is just how you understand your data frame. So most of us, we understood this, and I don't see why that is a big issue. But I just believe you've gotten or you are cleared on that now. So just if you are still confused on categorical variables, you can look it up. You can watch videos on that on YouTube, or you can even DM me to with specific questions, and I can answer you definitely if I see your message. So let's just leave it at that. So Timothy, I don't know. Are you okay? Is the question or the answer
Yeah,
satisfactory?
I'm okay, sir. But what I was trying to say is, there's some product ID that they are numerical numbers, like not really. I get that once I use df.unique, I can always know if it's categorical. Thank you, sir.
Yeah. All right. I don't even get what you said. Like that, there's some product ID that are numerical. Do you mean like there are some values in product ID that is numerical?
Yes, like there are some product IDs. Most product IDs, if you check product IDs of some documents that we buy, they are mostly numericals.
Okay. I think I get what you're saying. Like no. Don't use the you work with the data set you have. Like you don't use the knowledge of some other data that you've worked with to start interpreting what you have. You use the one you are seeing currently to work or to inform a decision on how to encode your data or do any preprocessing or whatever it is that you're doing. You understand? So in this case,
Yes,
our product ID is categorical. So it doesn't concern you whether other product IDs are numerical or not. Do you understand?
yes, sir.
So you work with your data. You let your data speak to you. You don't speak to your data. So Solomon, you go last, and then we'll round up for today. Yeah, you're on mute now, Solomon. You can ask your question. Yeah, Solomon, are you there?
Yes, can you hear me? Good evening.
Yeah, I can hear you.
Yeah, thank you. Yeah, you said something earlier and drew my attention regarding people maybe trying to do assignments and maybe due to cut error and they stop without knowing how to trace the error. That drew my attention very well. So it's going to be of good help to me, especially because most of the time it got me discouraged. And secondly, I like just like what Mr. Kim said, Kim's Stefano David. I think I have similar issue last week during submitting. I mean, last 2 weeks during submitting that Google form. So I was done with my assignment, but eventually my system went off and there was no light, only for me to just come back again and I was unable to submit it. So I DM you regarding it. So please, check those things for us so that we can, go through well. Thank you.
All right, no problem. So yeah, the first one is very important. Dealing with error is a skill you should have as a programmer. Um, you can mute yourself, please.
Okay, okay.
Yeah, so the error part, that's what I said. I will try to see if we can get time to just go over it. And I'm not promising anything, but once we can bring out time, we'll definitely see how we can do that. Or probably I will send in a video that we can watch, and then um, just it will help us to navigate these errors. So, but I've just given us, and that's why most of the time when I'm coding or when I'm writing code, sometimes we encounter errors live on class, and you see how I quickly debug it or I ask questions what exactly. So these are just implicit ways of like trying to teach us or trying to get us to be comfortable with reading error messages. So you sometimes you can just copy out the error code at the end, paste it on Google. You see other people that have encountered similar errors. You check their code. This process actually um, improves your thinking, improves you as a programmer, and helps you understand better how to program. Honestly, like if you can fix error on your own, you'll be a very, very good data scientist. So, but that I think is usually not easy at the start, which is very understandable. So, but this is just what I can say at this point. But subsequently, if we can have maybe next week, if we can have a free time, let's say 20 minutes before our class or after our class, then we're going to look at that. But I'm not promising anything. Yeah, so that's it. And for your second question, you said you had similar issue. So you have just DM me, just send me a DM regarding that. So we don't spend much time on that. So we're going to be closing in, drawing the curtain now, because time has been fast spent. This is about 30 minutes overshoot. So thank you very much, everyone, for sticking with us to the end. I really commend the effort that you put on your own part, right, to learn. I understand that we have a lot of things doing, but the fact that you're bringing out time to dedicating time to learn is actually very impressive. So just keep it up, and I believe we are going to see the end of this program. So yeah, that's it. I don't know. I don't have any other thing to say. So just keep up, or just pay attention to the information that will be posted on the Google Classroom. Your assignment to be given after tomorrow's class. So, and the recording for this class, I'll try as much as I can to drop the link this night, so you can watch it ahead of tomorrow's class. So yeah, thank you very much, and have enjoyed the rest of your day. And don't
Thank you
forget
very much.
to drop what you learned on the live class. Please just drop what you learned on the live class, and how the class was, the experience and everything. So we can all so we can all learn too. Thank you very much.